Our team, pre-trained monkeys, decided to evaluate NLP methods for generating titles for news articles. Our dataset is the BBC dataset containing titles and content of news articles. We decided to do two approaches. The one approach is to train a LDA model, which is taking the content of the news articles and is creating the most frequent topics. These topics then are used as an input for a GPT model, which is generating a title based on our most frequent topics. The other approach is taking the text-to-text transfer transformer model, training it with our titles and contents, and giving it new contents to generate new titles. And afterwards, we are comparing the two models and seeing who performed better.
Hello, I'm Xianzhe. In this project, I'm responsible for T5 model. I will introduce you the T5 first half part. At the beginning, we import the library we need here. And on the step 1, import the data set. We use for loop to import all data. As you can see, the first column is original title, the second column is original article, and we use two validation to check out the data is loaded correctly or not. And we can see how many rows of data we have here. On the step 2, we process the data. Firstly, we download the resources we need here, and we clean off text. We remove characters and punctuations. After that, we remove stopwords. Stopwords is like is, and they don't have concrete meaning, so they was like functional word. At the 3 parts, we do the lemmatization and stemming. We will transform running to run, convert books to book. It's like this. On the 4th part, we do the normalization. That is because we want to reduce the impact of case sensitivity. So we're converting all letters to lowercase. At the end of this part, we do the tokenizations. We combine all of this into one function. We just play it, you can process your data. But the most important thing is you need to vectorize it, because our natural model, they don't know natural language, they just know vector. So we should use vector to express one word. At the end of this part, I choose word embedding here. On the step 3, here is model building. At the beginning, I defined the model name is T5 base. I didn't define any specific layer of neural network because we use a pre-trained model. And at the second part, we define the training arguments here. We use the default parameters because we could adjust in training process. At the end of this part, we compile models by choose optimizer. We use add-on optimizer, and we use cross entropy as our loss function.
We're now ready to begin fine-tuning our model. From our process data, we separate 10% for our testing, and we save it to a CSV file. Then we configure our environment. We check if a GPU is available. We load our T5 model and its relevant tokenizer. And then we process our dataset. From that dataset, we reserve 90% for training, and we take the rest into our validation set. We finally configure our training arguments. We did a time versus performance trade-off, and we chose 16 epochs because it was taking a significant amount of time to train each epoch. And then we configured our trainer module. Finally, we trained the model and we saved it into a local directory. To test the outcome, we created a function that does the same pre-processing as the input. We load the model again and configure the environment. Finally, we tested on one sample first. When we finish processing our test set, we can display the results. Here we can compare our process title to our generated title, and we see that there's a reasonable amount of effectiveness for how small the model we chose is. Finally, we evaluate our model. These evaluation tests take up to 8 minutes to run for every single time, so we're going to refrain from running them in this demo. But the Rouge scores are given here, and we discuss the interpretation for these Rouge scores in our report. We also calculated a Meteor score and a Blue score. Once again, these results are discussed in our report. We do notice that these scores are very low, but for a title generation task, which is a creative task, we aren't relying too heavily on a significant reproduction of the test information. We're relying on a creative generation of a title. We compared the results for our fine-tuned T5 model against a foundation model like Google Gemini, and we can run that on 10 randomly selected rows from our test set as well, and we can see that this does a far better job than our T5 fine-tuned model. So in conclusion, the fine-tuned model is only a useful experiment when you can do it on a significant amount of training resources. Otherwise, relying on foundation models is probably a better thing to do for both cost and time.
The latent Dirichlet allocation model, also known as LDA, which is a generative approach for statistical clustering. So the model is fine-tuned to return clusters based on similar words within context, and then we will then use those words returned to then feed into the T5 transformer for text generation. So in order to use the latent Dirichlet allocation model, we will first of all install PyLDA-viz just for just to visualize the data. So I've gone ahead and actually installed it. So we will just skip that for now. So in order to use the LDA model, we will be using NLTK, but also spacey matches is perfectly okay. We will be specifically using WordNet and stop words. Stop words is important for pre-processing, and same as WordNet as well. Right, and so we'll go ahead and actually run this. Then we will do some pre-processing. So the pre-processing is fairly standard. We will tokenize each word. We will remove all of the stop words, and then we will lemmatized it. So it will break down all of the words into its roots. And so what we're going to do is we're going to normalize all of the words by transforming them into lowercase, and then we will return all of the tokens. Here, I've made the assumption that the BBC topic dataset has an abstract header. This is purely for the sake of convenience. And then finally, we will actually run the LDA model itself. So we'll go ahead and actually run this. And then while it's running, I will briefly talk about the model itself. So the model is basically trained on a corpus, which is actually just a document itself. So we'll have a collection of documents, the document essentially being the data set itself, which is composed of a title and an abstract. For fine-tuning, we set it to 20 number of topics, and we decided to give it 10 passes. So as you'll see in the visualization later on, it is actually a fairly good fine-tuned model, although it could be a little bit better. There are not too many overlapping clusterings. So here we're just getting the keywords from the text. So the text itself will then have all of the keywords that are based on the most relevant topic. So it will return the most relevant topic and then the top keywords from that topic itself. Right, and we'll go ahead and run this. And then we should run this, and you can kind of see that the top keywords were said, new, say, work, time, called, hard, come, core, thought, list, and found. Cool. And then we can actually visualize this. And there we go. So we can see that there's not too many overlapping clusterings, but a lot of them are fairly small. So that does give us some intuition as to, well, maybe there are actually too many topics. We don't actually need that many topics. But I think